On September 1st, 1859, humanity witnessed the most powerful solar storm in recorded history. What unfolded over the next few days would forever change our understanding of the sun's destructive potential. Across the globe, the night sky erupted in a dazzling display of colors. Auroras, normally confined to polar regions, were visible as far south as Hawaii and Cuba. The sky burned so bright that people could read newspapers at midnight. Earlier that day, amateur astronomer Richard Carrington was conducting his routine sunspot observations when he witnessed something extraordinary: an intense flash of white light erupting from the sun's surface. What Carrington saw was the first recorded observation of a solar flare, a massive explosion on the sun's surface that would unleash a wave of charged particles toward Earth at incredible speeds. Within hours, this cloud of solar plasma slammed into Earth's magnetic field, triggering one of the most intense geomagnetic storms ever recorded. The effects were immediate and devastating. Telegraph systems worldwide went haywire. Operators reported receiving severe electric shocks. Telegraph papers spontaneously caught fire, and some systems continued working even after being completely disconnected from their power sources. If the Carrington event happened today, the consequences would be catastrophic. Our modern world is far more vulnerable to solar storms than the Victorian era. Power grids could collapse across entire continents. Satellites would be disabled. GPS systems would fail. Internet infrastructure could be knocked offline for weeks or months. The estimated cost? Trillions of dollars in damage. Scientists aren't asking if another Carrington-level event will occur. They're asking when. In 2012, we missed a similar-sized solar storm by just 9 days as it passed through Earth's orbit. Today, we have an array of satellites and observatories constantly monitoring the sun for signs of dangerous solar activity. But even with modern technology, we would only have about 13 hours warning before a Carrington-level event struck Earth. To understand the raw power of massive solar flares, we need to journey into the heart of our star, where magnetic forces create the most violent explosions in our solar system. It begins with sunspots, vast regions where intense magnetic fields pierce through the sun's surface. These dark blemishes can be large enough to swallow Earth whole. Deep beneath the surface, the sun's rotating plasma twists these magnetic field lines like rubber bands. As they become more tangled, enormous amounts of energy build up. Eventually, these twisted magnetic fields reach a critical point. Like a cosmic rubber band stretched too far, they suddenly snap. The result is catastrophic. Magnetic field lines explosively reconnect, heating plasma to temperatures hotter than the core of the sun itself. 20 Earths could fit inside a single one of these plasma loops. The energy released in a single massive solar flare is almost beyond comprehension. A powerful solar flare releases more energy in a few minutes than humanity has produced in our entire history. It's equivalent to detonating 100 million of our largest hydrogen bombs simultaneously. The most powerful flares are often accompanied by coronal mass ejections, massive clouds of magnetized plasma that blast outward at millions of miles per hour. These plasma clouds create shock waves that ripple through the solar system, distorting the magnetic fields of every planet they encounter. The sun's surface is rarely quiet. At any moment, dozens of smaller flares are crackling across its surface. But it's the monsters, the X-class flares, that pose the greatest threat to Earth. These cosmic dragons remind us that our sun, giver of life, also has the power to devastate our technological civilization in an instant. And someday, perhaps sooner than we think, another Carrington-class monster will awaken. 4 billion years ago, Mars was a very different world. Oceans of liquid water stretched across its surface, protected by a thick atmosphere and a powerful magnetic field. But something catastrophic happened. Today, Mars is a frozen desert. Its atmosphere is less than 1% as thick as Earth's, and liquid water can't exist on its surface. The story of how Mars lost its protective shields is a warning about the raw power of our Sun. The trouble began when Mars lost its internal magnetic dynamo. Unlike Earth, which maintains a liquid rotating core, Mars's smaller size meant it cooled more quickly. Without an active core generating a magnetic field, Mars became vulnerable to the Sun's constant assault. Like a shield dropping in the middle of a battle, the planet was exposed to the full fury of solar storms. And before you hit that subscribe button to follow our cosmic journey, let me show you something incredible that NASA's MAVEN spacecraft discovered about Mars's ongoing atmospheric loss. MAVEN revealed that even today, Mars loses about 100 grams of atmosphere every second to solar wind. During solar storms, this rate can increase by a factor of 10 or more. The spacecraft caught solar storms in the act, watching as huge clouds of Mars' already thin atmosphere were torn away into space, never to return. But the most devastating losses likely occurred billions of years ago, when our younger sun was far more active and violent. The young sun bombarded Mars with solar storms up to 100 times more powerful than what we see today. Without a magnetic shield, these storms gradually stripped away Mars' atmosphere like a cosmic sandblaster. As the atmosphere thinned, Mars's oceans began to boil away into space. The planet's surface water evaporated, leaving behind only the frozen poles and underground ice we see today. Mars serves as a sobering reminder of how crucial magnetic fields are for planetary protection. Every time we observe another solar storm stripping away Mars's atmosphere, we're watching the final act of an ancient cosmic catastrophe. Just when we thought we understood the limits of stellar fury, astronomers discovered something that made the Carrington Event look like a cosmic sparkler. In 2012, NASA's Kepler Space Telescope detected something extraordinary: stellar explosions of almost unimaginable power, erupting from seemingly normal stars like our Sun. These events, dubbed Superflares, release up to 10,000 times more energy than the largest solar flare ever recorded on our Sun. A single superflare can release more energy in minutes than our Sun produces in a month. The plasma ejected during these events could easily engulf entire solar systems. These cosmic behemoths are powered by star spots, dark regions of concentrated magnetic energy that can grow to cover up to a quarter of a star's surface. For comparison, the largest sunspots on our Sun rarely cover even 1%. But what happens to the planets orbiting these volatile stars? The answer is troubling for the search for life beyond Earth. When a superflare strikes an Earth-like planet, the results are apocalyptic. The energy released can strip away huge portions of planetary atmospheres in a single blast. Surface temperatures can spike by hundreds of degrees in minutes. These discoveries are forcing scientists to redraw the boundaries of what we call the habitable zone, the region around a star where life could potentially exist. Most stars capable of producing superflares are young, active stars similar to what our Sun was like billions of years ago. This revelation suggests our own solar system may have endured similar cosmic assaults in its youth. Early Earth and Mars would have faced superflares that make the Carrington Event seem gentle by comparison. The discovery of superflares raises an unsettling question. Could our mature Sun still be capable of producing one of these monsters? While most scientists believe our Sun has settled into a relatively stable middle age, we can't completely rule out the possibility. A superflare on our Sun would make the Carrington Event look like a mere preview of solar fury. Earth's magnetic field is our first and most crucial line of defense against the Sun's fury. This invisible shield has protected life on our planet for billions of years. Generated by Earth's liquid metal core, our magnetic field extends far into space, creating a protective bubble called the magnetosphere that deflects most of the sun's harmful radiation. But this shield isn't perfect. When powerful solar storms hit, they can compress our magnetosphere and find weak points, particularly near Earth's poles. This is why we see auroras, beautiful reminders of our atmosphere under attack. Our technological civilization has created new weaknesses in our natural defenses. Long metal structures like power lines and pipelines can act as giant antennas for solar storm-induced currents. During intense solar storms, these induced currents can overload transformers and cause cascading power failures. The most vulnerable regions are those built on ancient rock, where electrical currents can't easily flow into the ground. Today, we have an unprecedented network of solar observatories watching for signs of dangerous solar activity. A fleet of specialized spacecraft constantly monitors the sun from multiple angles, giving us early warning of potential solar storms heading toward Earth. When a major solar storm is detected, we typically have between 15 and 45 minutes to respond. Power companies can adjust their grids, satellites can enter safe mode, and critical systems can be protected. Scientists and engineers are racing to harden our infrastructure against the next major solar storm. Some of their solutions are ingeniously simple. New transformer designs include automatic shutoffs that trigger during geomagnetic disturbances. Space weather forecasting has become as crucial as traditional weather prediction for protecting our power grid. It's not a question of if another massive solar storm will strike Earth, but when. The good news is that we're better prepared than ever before. Our increased understanding of solar storms and improved technology gives us a fighting chance against even the most powerful solar events. But we must remain vigilant. As we wrap up our journey through the sun's most powerful eruptions, remember that we live in the atmosphere of a star that can unleash unimaginable power at any moment. Thanks for watching, and don't forget to subscribe for more videos about our fascinating cosmos.